All of fractions. Terms and types, methods to work with fractions, conversion between fractions and decimals. This is not going to show the why it works, just the how. So this is useful for revision. If you know all of this, great. If not, better revise. I'm going to use examples that are probably a bit more difficult than the ones you will see, but it will encourage you that you can do them. Now, if you do want to know how these work in further detail or why they work, there are other videos showing that. Basic terms of fractions. Integers. These are the whole numbers. They can be negative. Here we have some integers in order. There's 0 is an integer, and they can be positive. They're whole numbers. Fractions are used to express numbers that occur in between integers, or amounts that you find that are not integers but somewhere in between. Fractions are written in the form of a over b, where a and b are both integers. For example, 4 over 9, with a line between them. Some numbers can't be written like this. The ones that can be are called rational numbers, and the ones that can't be are called irrational numbers. So pi, which is 3.1415926 and goes on forever with no recurrence, no repeating part, and square root of 2, which is 1.414213, and that goes on forever with no recurrence, are examples of irrational numbers. They cannot be written as fractions with complete accuracy, only approximated. And the decimals for these never end, but they have no recurring part. Parts of a fraction. The number you find on the bottom is the denominator. That shows how many parts a whole one has been divided into. The number on the top is the numerator. It shows how many pieces we have. So a fraction like a over b, a is the numerator, that's the top, b is the denominator, that's the bottom. For example, 4 over 11, 4 is the numerator, 11 is the denominator. And what this means is we've got 4 pieces where each piece is the size of, and then we look at the bottom, 1 whole divided into 11 equal pieces. Other ways fractions can be expressed. Fractions such as a over b is equal to a divided by b. For example, 11 over 17 is equal to 11 divided by 17. You get the same quantity or amount or number, the same number, if we divide the numerator, which is the top of a fraction, by the denominator, which is the bottom. And here we see that any number such as a can be written as a over 1. So this a is not a fraction, but written like this, a over 1, it is a fraction. Of course, a divided by 1, and we've just been through that here, is equal to a. So, for example, 13 can be written as a fraction, 13 over 1. Any integer can be written as a fraction with a denominator of 1. And of course, you can go the other way. 13 divided by 1 or 13 over 1 is a fraction, can be written as just 13. Types of fraction. Common fractions, the fraction is expressing a ratio of 2 integers rather than as a decimal. So there's an integer 3, there's an integer 4, this is a form of a ratio. I won't go into why that is, but that is a fraction, a common fraction. It's equal to 0.75, but this is a decimal. 0.75 is not a common fraction. 3/4 is a common fraction. Proper fraction is one where the numerator is smaller than the denominator. So here we've got 19, that's smaller than 36, so that is a proper fraction. An improper fraction is one where the numerator is larger than the denominator. For example, 117, which is bigger than the bottom, which is 80. This is an improper fraction. A reducible fraction is one that doesn't use the smallest possible integers. If it did, it would be a simplified fraction. For example, 15/25, these numbers can be made smaller and it can remain equal or unchanged in amount. It can be written as 3/5. We'll look at how to do that in a minute. But this 15/25 is a reducible fraction, and it can be simplified to 3/5, which is a simplified fraction. This can't be simplified further. If it could be, it would be a reducible, not a simplified fraction. Now I've dealt with here the numerator if it's smaller than the denominator, and here if the numerator is larger than the denominator. So I know you're going to ask what happens when they're the same. So I'll put that down here. When the numerator and denominator are the same, the quantity is 1. For example, 14/14 is equal to 1 whole 1. 14 divided by 14 is 1, and 14 pieces, where each piece is the size of a whole cut into 14 pieces, means you've got the whole thing, which is 1. Mixed numbers. These are ones containing a whole number integer, which is an integer part, and a fractional part. For example, 3, there's the whole number integer part, and this 19/36 is the fractional part. And we think of this as 3 whole ones plus 19/36 as a fraction of a further whole one. It's not 3 times 19/36. So when we write it like this, it's 3 and 19/36. And these always express numbers greater than 1 because this integer here is going to be 1, 2, 3 or 4 or something like that, plus the fractional part. Compound fractions, these are ones where the numerator and or the denominator are themselves fractional in some way. So for example, here's the line, the big line. The numerator is 2/3, that's a fraction. And the denominator is 3 and 19/36, and that is fractional as well. You don't tend to come across these very often in your GCSE type work. Other terms that we use when dealing with fractions: LCM, lowest common multiple. A multiple is a number that is produced by multiplying one number by another. For example, multiples of 12 are 12, 24, 36, 48, 60, 72, and so on. Multiples of 18 are 18, 36, 54, 72, 90, and so on. And you'll see these are just the times tables. This is the 12 times table. This is the 18 times table. Multiples of n are n, 2n, 3n, 4n, 5n, 6n, and so on. A common multiple is one that is common to 2 or more numbers. So common multiples of both 12 and 18, we look along these lists of multiples and find numbers that appear in both lists. and we find 36 and 72. So these are common multiples, and there are others if these lists were longer. The lowest common multiple, or LCM, is the smallest of the common multiples. So in this case, the smallest one is 36, smallest common multiple, so it's 36. Now there are methods involving prime numbers to find the lowest common multiples, but I'm not going to look at these today. We're looking at fractions. Other terms, HCF, highest common factor. A factor is a number that divides exactly into another number. For example, factors of 12 are 1, 2, 3, 4, 6, and 12. These all divide exactly into 12. Factors of 18 are 1, 2, 3, 6, 9, and 18. They will divide exactly into 18. A common factor is one that is common to two or more numbers. Common factors of both 12 and 18. Look along the list, find the ones that appear in both lists. They are 1, 2, 3, and 6. The highest common factor, or HCF, is the largest common factor. These are the common factors, and the largest one is here, 6. The highest common factor of 12 and 18 is 6. There are methods involving prime numbers to find highest common factors. We're not going to look at these today. We're doing fractions, looking at methods to work with fractions. Firstly, simple techniques operating on only one fraction. Then we're going to look at arithmetic methods operating on more than one fraction. We're going to see how to order fractions, finding fraction of another number, and expressing one number as a fraction of another. Reducing, simplifying, cancelling down. These terms all relate to expressing fractions in the smallest possible numbers, also known as the lowest terms. It's considered tidy or elegant to express answers to calculations that are fractional in the lowest terms as simplified fractions, and you should always do this where possible. The method is to divide the numerator and the denominator by the same number, which must be a factor of both. It must divide into both. Use the HCF, highest common factor. If you do this, you only do the calculation or the division once, or you could use any common factor, but you might have to repeat that a number of times until there are no further common factors except one. We can reduce 18 over 42. The highest common factor of 18 and 42 is 6. So we divide 18 by 6, that gives 3. 42 we divide by 6, that gives 7. 3 over 7. And because we use the highest common factor, this is reduced to its lowest terms. If we didn't use the HCF, we could do it this way. 18 over 42, we find any factor of those two. A factor of 18 and 42 is 2. That divides into both. 18 divided by 2 is 9. 42 divided by 2 is 21. But this is not in lowest terms. It has factors that divide into both. A factor of 9 and 21 is 3. So divide 9 by 3, 21 by 3. 9 divided by 3 is 3. 21 divided by 3 is 7. There are no further common factors apart from 1, so this is now in lowest terms. Converting mixed numbers to improper fractions. Example, we've got 3 and 19 over 36, and we've got to convert that to an improper fraction. Remember, improper is where the top's bigger than the bottom. The method is to multiply the whole number part by the denominator and add it to the numerator. So if we have n as the whole number part and a over b as the fraction, it's n times b, that's this number here times that one, and then we add what we had on the top to begin with, which is the a, and it's all over b, the denominator we had before. Here's a worked example, 3 and 19 over 36. So we take the 3 times the 36, 3 times 36, and we add what we had as the numerator before, that's 19, and it's all over the old denominator of 36. 3 36s are 108. We add the 19, that gives us 127, and it's all over denominator 36. And the result will always be an improper fraction because we're dealing with a quantity bigger than 1, thanks to an integer here. And generally, you must convert mixed numbers to common fractions to use the following mathematical techniques on them. Don't leave them in this form, convert them to that form. Converting improper fractions to mixed numbers. So this is doing what we've just done in reverse. The method is to divide the numerator by the denominator, and the integer quotient, the integer part of the result, becomes the whole number part, and the remainder becomes the numerator. Given c over b, c divided by b is equal to some integer part n with a remainder part a. And we don't do this as a decimal, we do it as a something remainder something else. And then we write that as the integer part n with a over the denominator b. Worked example 127 over 36. We divide 127 by 36, and that gives us 3, remainder 19. So we write that as 3 and 19 over 36. You can only do this with improper fractions, where the top's bigger than the bottom, because otherwise you don't get any integer part. If you get an answer that is an improper fraction from some other type of calculation you're doing, convert it to a mixed number for tidiness. Scaling up to a preferred denominator. For example, we've got the fraction 7 over 11. I want to express this with a denominator of 132. What am I going to put on the top? The method is to find the integer that multiplies the denominator to give the preferred new denominator. Then once you've found that integer, you multiply both the numerator and the denominator by this number. A over b, we multiply the top and the bottom by the same number, which is one we've found to give us what we want on the bottom. So that gives an over bn in this case. An example of this, express 7 over 11 with a denominator of 132. So there's what we start with, 7 over 11, and what converts 11 into 132 is multiplying it by 12. So we've got to multiply the top and bottom by 12. 7 12s are 84, 11 12s are 132. And this could be simplified, but I haven't done that here. The preferred new denominator must be a multiple of the given denominator. There has to be an integer number that you can find. In other words, the given denominator must be a factor of the preferred new denominator. Now moving on to arithmetic involving 2 or more fractions, how to multiply fractions. So for example, 9 over 8 multiplied by 2 over 3. The method is to multiply the numerators together and multiply the denominators together, then simplify if you can. So given a over b times c over d, the answer is a times c, that's the two tops multiplied, over b times d, which is the two bottoms or denominators multiplied. So the worked example, 9 over 8 times 2 over 3. We do the tops 9 times 2 gives 18. The bottoms 8 times 3 gives 24. And we simplify that to 3 over 4 or 3/4. This stage, it may be possible to do some cancelling down. And I'll show you that in a second. That helps to keep the numbers small during multiplication. Here we are cancelling down. When either the numerator or the denominator consists of a set of numbers that are all multiplied together, you can cancel down any top number with any bottom number using common factors to those two numbers. For example, here we've got 9 being multiplied by 2 and 8 being multiplied by 3, so it's multiply all the way there, multiply all the way on the bottom, so we can use this method. We see that 9 and 3 both have a common factor of 3, so divide both of these numbers by 3. Instead of 9, we divide that by 3 to give 3. Here, instead of 3, we divide that by 3 to give 1. And the other two numbers, we just write them as before. So now we've got 3 times 2 over 8 times 1. And we see that both 2 and 8 have a common factor of 2. So we can divide both of these numbers by 2. One's got to be on the top, one's got to be on the bottom for this to work. Can't do this with two numbers on the top or two on the bottom. But here we go. So 2 divided by 2 is 1. 8 divided by 2 is 4. The other ones just get written down as they were. So 3 times 1 over 4 times 1. Now we can multiply because there are no more common factors apart from 1. We do the multiply and we end up with 3 over 4 3/4 as before. Dividing fractions. Example 9 over 8 divided by 2 over 3. The method is to turn the second fraction upside down and then multiply. Simplify if possible. So given A over B divided by C over D, that's equal to A over B multiplied by the second fraction upside down. So where it was C over D here, when we had to divide, we write this the other way up, so it now becomes D over C. And then we do a multiply here instead of a divide. And we've just seen how to do multiplies. And that will give us A times D over B times C. So the worked example, 9 over 8 divided by 2 over 3 is equal to 9 over 8 multiplied by, and here it is upside down, instead of 2 over 3, I've written 3 over 2. And that's 9 times 3 over 8 times 2, which is 27 on the top, divided by 16 on the bottom. That is an improper fraction, so we can write it as a mixed number 1 and 11/16. We could do some cancelling down at this stage if it was possible using the cancelling down method, but it is not possible here. So moving on to adding and subtracting fractions. You can only add or subtract fractions that have the same denominator. That's not the same for multiplying and dividing. We don't need the same denominator, but for adding and subtracting we do. So we may have to adjust the fractions so they do have the same denominator. If it's a mixed number, convert it to fractional form. Then find the lowest common multiple of the denominators. Use that to adjust each fraction so the denominators are the same. You then do the addition or subtraction to the numerator only, and simplify or convert to mixed number as needed. An example, we've got 9 over 8 plus 2 over 3 or 9 over 8 minus 2 over 3. This plus minus sign just means we're doing either the plus or the minus. It's the same for both operations. Or the process is the same. So we're looking for the lowest common multiple of the denominators. This is it in symbol form, a over b plus or minus c over d. We're looking for something to multiply the top and bottom of the first fraction by, and then we're looking for something, it's going to be something else, to multiply the second fraction top and bottom by to give it the same number on the bottom, which is the lowest common multiple. In other words, b times m should be the same as d times n. And then we end up with a times m on the top here over the lowest common multiple, plus or minus, depending on which sign we've got, c times n over the lowest common multiple. And then we can write that over the lowest common multiple as am plus or minus cn. Bm and dn, these bottom bits here, are the same, and they are the lowest common multiple. So a worked example, that's a bit hard to digest, I know. 9 over 8 minus, I've decided to use the minus one here, 2 over 3. So the lowest common multiple of 3 and 8 is 24. So I need to convert both these fractions to have 24 on the bottom. For 8 to be 24, I've got to multiply it by 3. 8 times 3 on the bottom, that means I've got to multiply the top by 3. 9 times 3. Second fraction, I've got to multiply the 3 on the bottom by 8 to give 24, so I do the top times 8. And that gives me, for the first fraction, 9 times 3, 27. 8 times 3, 24. And I've got the minus, and then the second fraction, 2 times 8 is 16, 3 times 8 is 24. They've got the same denominator. So now I can add or subtract, in this case subtract the tops, which gives me 27 minus 16 over 24, and that is 11 over 24. I can't simplify that any further. Finding a common multiple for the bottom or denominator when you're adding or subtracting. You can always find a common multiple simply by multiplying all the numbers together. For example, if these were the bottoms of our fractions, one was 8, one was 3, and one was 11, we wanted a common multiple for all of these. We can find a common multiple simply by multiplying them all together. 8 times 3 times 11 is 264. In 264, 8 is being multiplied by 3 times 11. So 8 is being multiplied by 3 times 11, or 33. 3 is being, this one here, is being multiplied by 8 times 11. That's the other two, 8 times 11. And 11 is multiplied by the other two, which is 8 times 3. In other words, by all the other numbers. This might give you the lowest common multiple, but might not. It will be a common multiple, but it might not be the lowest. Example, given 12, 24, and 48, the above method gives 13,824, but the lowest common multiple of 12, 24, and 48 is in fact 48. And that is much easier to work with. Ordering fractions, putting them in order. For example, list in decreasing size order 3 fractions A, B, and C, and they have these values. The method is to express each over a common denominator. Then the largest one has the largest numerator. So for these ones here, 8, 3, and 7, I'm going to use a common denominator of 168. And I have got that in this case by simply multiplying these three numbers together. and it happens to be the lowest common denominator. So for fraction A, which is 9 over 8, I'm multiplying this by a number that gives me 168. And that number, because I'm using this one, it's just 3 times 7, or 21. It's the other two. So 8 times 21 on the bottom gives me 168. I've got to do the same to the top. 9 times 21 gives me 189. For B, which is a mixed number, convert it first to a fraction, where it becomes 4 over 3. I multiply both of these by 56, and that is 7 times 8, because I'm dealing with the 3, it's the other two, 7 times 8, 56, and I get 168 on the bottom, 224 on the top. And the last one, 8 over 7, multiply it by 8 times 3 on the bottom and the top, 192 over 168. And I look at the tops and I see which one is the biggest. It's this one here, 224. So that's the biggest. And it asks for it in decreasing size order. So it's biggest first. The next biggest one, I look at the remaining two, is 192. And that's C. And the smallest one is A. So that goes last. So it's A. So that is the order. Finding a fraction of another quantity. Here's the example. What is 3/7 of 19? You must remember that of means multiply. So simply do a multiplication. 3/7 of 19 is 3/7 times 19. And I've written this as 19 over 1. Don't really need the 1, but it's just to use the same method as we used when multiplying two fractions together. And that gives me 3 times 19 over 7, or 7 times 1 if you like. 3 times 19 is 57, 7 times 1, or just 7 on the bottom. And then we can write that as 8 and 1/7. If the second number is also a fraction, for example, if this had been 19/64, 19 over 64, instead of an integer number, just multiply them as fractions. Remember, of means multiply. Express a number as a fraction of another. For example, express 18 as a fraction of 63. Here we can see the word of again, and of means multiply. So write out the equation as it would have been done forwards, and then just rearrange it. So the key phrase here is fraction of 63, which means a fraction is multiplying 63. So here's our fraction, A over B, that's some fraction, that's what we've got to find. And then here's our of, that's the multiply sign there, and then 63. So we know that a fraction times 63 gives us 18. And so the worked example, we know A over B times 63 is 18. So we divide both sides by 63 to move it from here, and it appears under the 18. And this is our fraction. A over B, some fraction, is 18 over 63. So that's what we're looking for. Express 18 as a fraction. And there it is. Look, 18 over 63. And we can simplify that to 2 over 7. And make sure you write the numbers the correct way round. Fraction of n, some number n, means n is multiplying the fraction and not the other number. So don't do the fraction times 18 in this case, because you see 18 there. Fraction of 63 means fraction times 63. Write it out like that. Converting fractions to decimals. For example, 127/36 converted to a decimal. And as I'm sure you know, this dot here means that this integer underneath 7, or this number, is repeated continuously forever, recurring. As we say, 3.527 with a 7 recurring. The method divide the numerator by the denominator. So this is a long division, 36, that's the denominator, divides into the numerator. I'm not going to go into how the division is done. That's another subject, but this is fractions. The answer is 3.527777, and that would go on indefinitely. So it's 3.527 with the 7 recurring. Use your calculator or long division. And this is always going to produce an ending decimal, which doesn't have a recurring part, or it's going to produce a recurring decimal. Converting decimals to fractions, going the other way. Decimals that go on indefinitely without any recurrence, like pi, these can't be converted into fractions. They're the irrational numbers. Other decimals that either end, or that they've got a finite length, or that recur, can be converted into fractions. These are rational numbers. Converting decimals that end into fractions, these are the finite ones. For example, 3.528, no recurrence there. What we do is we write the decimal as a fraction over 1, and then multiply the top and bottom by 10 to the power of n, or that's 10, 100, 1,000, 10,000, whatever we need, to make the top into an integer, and then cancel down, if possible, to lowest terms. So given 3.528, we write that as 3.528 over 1. We then multiply the top to make it an integer. So the decimal point's going to shift 1 space, 2 space, 3 spaces. So we multiply it by 10 to the power of 3, or 1,000. We multiply the bottom by the same number, always the same number, to multiply top and bottom. And that gives us 3.528 over 1,000. Simplify that down, we get 441 over 125. Decimals that recur to fractions. It's hard to take in all at once. We'll see how it works, and then we'll recap it. But the method is, call the decimal you're given something like A. It doesn't have to be A, it could be Z or B or whatever. So A equals your given decimal. Write the numbers of the decimal, no decimal point, no zeros, just the digits. Above it, write the numbers of the decimal again, but shifted so that a subtraction eliminates the recurring part but leaves something, not 0. It's got to leave something. And this shifting bit, we'll see how that's done in a minute. Decide where to put the decimal points so that the result of subtraction is the smallest integer possible. Then write alongside each what multiple of the original decimal each number represents. Then you can do the subtraction to both parts and rearrange. So this bit here looks a bit confusing, but it is quite straightforward when you see it done. It's an example using a recurring decimal, 3.5234, and the 2 dots over the 3 and the 4 show that the 3 and the 4 repeat indefinitely. So in reality, this is 3.5234343434, and so on, never ending. To convert that into a decimal, we first write A equals whatever we were given. So there we have A. write the numbers of the decimal, and I haven't bothered with any leading zero or decimal point here, just the digits. Above it, you write the numbers of the decimal, again, shifted so that a subtraction eliminates the recurring part but leaves something. So in this case, I've written an additional 35234 above my original 35234, and I've got here, not shown, but because it's recurring, an additional 3 in that position and an additional 4 in that position. And when I subtract this 3 and this 4 from the top line, it's going to leave me nothing here, but it's going to leave me something over here from this part of the subtraction. This is the correct way. What you mustn't do is line it up like this, so that although this has got a 3 and a 4 on the top and a 3 and a 4 on the bottom, that's the repeating part, if I do that subtraction, I'll just end up with 0, because the number's just written down exactly over the top and you end up with nothing. So do it like this. You're going to have to shift it one full pattern of the recurring bit at least. So this is where we got to. Once you've got to there, you decide where you're going to put the decimal points so that the result of the subtraction is the smallest integer possible. So I'm thinking I want it here, where this blue line has been drawn, and therefore writing that out gives me this. Now what I've done is, instead of putting the recurring dots over this 3, 4, I've added the missing, or the first repeated 3, 4 and put the dots over those. And the only reason I've done that is because if I'd left this as it was, 3, 5, 2, 3, 4 decimal point and nothing here, it would just look a bit strange to have a decimal point not followed by anything. Once we've got to here, we write alongside each of these numbers what multiple of the original decimal each number represents. So the original decimal was this. A is 3.5234. This number here with the decimal point there is 10,000 times the original. That number there with the decimal point there is 100 times the original. So this is really what we're aiming to get to from doing all of that. We then do the subtraction to both parts, that is the decimal bit and the bits that have got multiples of A in them. We subtract, we get 34882 point nothing in this case, and that's what we're aiming for, is to have nothing there to make this an integer. And on this part we get 9900A, and we rearrange that. So I've dropped the decimal point here, I don't need that because it's an integer, and therefore dividing both sides by 9900, we get A is 34882 over 9900, and we can simplify that to this number here. So just to recap on that method, now that you've seen it, this should make more sense. You write the decimal down as being equal to A. You write the numbers of the decimal. Don't worry about the decimal point, any leading or trailing zeros. Above it, you write the numbers of the decimal again, and you shift it to the left so that a subtraction eliminates the recurring part but leaves something behind. Decide where you're going to put the decimal points so that the result of the subtraction is the smallest integer possible, and write alongside each what multiple of the original decimal each number represents, so like 100A or 1000A. Do the subtraction to both parts and rearrange. So summarizing, we've looked at parts of fractions and terms, methods to work with fractions, simplifying and reducing, scaling up, converting between improper fractions and mixed numbers, arithmetic operations, multiply, divide, add and subtract, ordering fractions, fractions of numbers, conversion of fractions to decimals, conversion of decimals to fractions, where you have a finite decimal, one that ends, conversion of decimals to fractions with recurring decimals. That is all. Goodbye.